So if you have trouble finding that again, please let me know. But 1.2 is going to be about measuring some things and constructing segments. The 1.1 stuff, that was very much about notation. So today, we'll throw a couple new terms at you, but we're going to be coming up with like some numeric answers, some things that you might think, oh, this is a little bit more math type. All right, but first, in geometry, we have things that are called postulates and axioms. It's not that terminology is not all that important. Those are things that are just kind of accepted, and then things that can be proved are called theorems. But you don't have to worry so much about that terminology. But this word, you do absolutely need to know what that means. Congruent. Okay, congruent. Congruent means they're the same size. So in students' language, it typically means they're equal, but equal really means numbers, like in math language. Equal means numbers, congruent means they're same size. So if we have congruent segments, like down here, A, B, and C, D, it means they both have the same length. And the way that we notate that is, notice these little dashes on there. That tells the reader they are the same length. So if you put a dash on each one, that means they are congruent or the same length. And you can put more, like if you put 2 dashes on this one, you just have to put 2 dashes on that one. Okay, so that again means they're the same length. Put 3 dashes on one, you put 3 dashes on the other, means they're the same length. Okay, so when they are congruent, this symbol right here, it's an equal sign with a little squiggle over it. Yes, that means congruent. That means they have the same length. Okay, as opposed to just an equation, or I'm sorry, just an equal sign, which means they are exactly equal. Like numerically, they are equal. So, and the reason I'm making a big deal about that word congruence is because in example 1 here, we are trying to determine whether these 2 segments are congruent. So we're just trying to see, are they the same length? So to do that, we're going to plot these points. So first, we're going to plot W at -2, 3. So remember, we always start at the origin. And I go to the left 2 and up 3. And we have a dot at -2, 3. And put a W there, okay? So we know that one's W. Then would you plot X at 3, 3? So that means I'm going to go to the right 3 and up 3. And put an X there. Then we have Y is at 2, 2. So I go over 2 and up 2. That's going to be Y. See the Y's over there. And Z is at 2, -3. So over 2 and down 3. So just remember, when you're graphing them, you do the X first, which means left and right, and the Y second, which means up and down. Obviously, if you graph it in the wrong spot, we're not going to get the right answers, okay? So this is asking us to find the length of WX. All right, well, let's find the length of WX. We're just trying to find this length here. When you count it, though, we're counting the spaces, not the corners. So it's like 1, 2, 3, 4, 5. Okay, so that has length of WX has a length of 5 units. If we want to find the length of YZ, segment YZ, I should be saying, that means from Y to Z. So again, counting the spaces, we've got 1, 2, 3, 4, 5 spaces there. All right, so segment YZ is a length of 5 as well. And so are they congruent? Yes, they are. They have the same measure. All right, so we're just essentially plotting points and determining whether or not the segments are congruent. So let's do the same thing here in part B. We have S is at -1, 2. So that's going to be here, which is in the second quadrant. If you remember, the quadrants go 1, 2, 3, 4. I'm going to plot -1, 1. So that's T. I have 3, -5. That's U. And I have 3, -2. So to find the length of segment ST, again, we're not counting the corners, we're counting the space in between them. So from S to T, that's just a length of 1. And from U to V, it's a length of 3. So are those congruent? Well, no, they're not the same measure. So congruency means they have the same measure. All right, let's go down here to the next part then. So we have an addition postulate, which just means we're adding together parts of a segment. So for example, here in problem number 1, we want to find the length of RT. Notice that RT doesn't have any segment above it or rock or ray or line. That means that we are finding the length of it. And so if we want to find the length of RT, well, we know from R to S is 17. From S to T is 21. So we just add those up. 17 plus 21. And RT has a length of 38. Okay, because they make up a straight line, we just add those two together. Same thing for KM. You know, this is 2, this is 6. And so the distance from beginning to end is 8. Okay, so we're just adding those things together. Part C is a little bit different because we got to do a little bit of thought here because it gives us different amounts. So we're trying to find the length of CD. It tells us that, you know, from the whole thing is 54, from A to D is 54. We know that from B to D is 36. And we also know from B to C is 20. So if from B to C, if from B to D is 36, and I know that BC is 20, well, that means that CD would have to be 16. Because 20 plus 16, you know, those two pieces are going to equal 36. Okay, so the length of CD is going to be 16. All right, so again, we're just starting off with some basics, but we're just talking about doing some measuring, plotting some points, being specific about notation. So are there any questions on either of the things that we did here today?